Let's imagine we have a radiologist. One thing a radiologist does every day, they look at images, for example, a CT image here, and then they write a medical report about the image. So they write down everything they can find in the image. Well, of course, writing a medical report is a really difficult and complex task, so they cannot do that directly after graduating from medical school. So they first have to get a little bit familiar with those images. So they have to be able to locate where all the anatomical structures are, so locate the different organs and bones and so on. And also they have to be able to find the relative positions between different structures. Is it more to the right, more to the left, or is it more to the back or to the front? So this is something they first have to know before they can actually write medical reports. And in the past, there already happened very bad things due to localization errors, even with experienced radiologists. So it happened that they did the operation on the wrong side because it was written on the wrong side in the medical report. Or they did the operation on the wrong vertebral level. Or they missed in an image that the tumor is near a vessel, which is an important information. So localization mistakes by radiologists had bad consequences in the past. So now let's imagine we have an AI model, a multimodal AI model like, for example, GPT that helps the radiologists. So now you can give the model an image and it writes a medical report, or it helps to plan an operation based on the image. But if the model should be able to do such complex tasks, they need to be able to localize anatomical structures in the images, and they also need to be able to detect the relative positions between different structures. Because similarly, as radiologists first have to know those stuff, also AI models need to know that. Because if they are not able to localize anatomical structures and find the relative positions, they will not be able to accurately describe the positions in a medical report or an operation plan. Well, and this could lead to the same severe consequences as I have described before, with, for example, wrong side surgeries or missing that the tumor is near a vessel. So an absolutely basic, fundamental requirement for the clinical use of those models is that they can localize anatomical structures and detect the relative positions between them. So nobody really tested that yet. So people were directly trying to use ChatGPT to write a complete medical report without first testing the basics for a safe use of those models. So when we give the model a CT slide like this and ask is the liver to the right of the stomach, the model should be able to accurately answer it if we want to safely use them for report generation or operation planning. So, and this is what we have investigated in our paper called Your Other Left, Vision Language Models Fail to Identify Relative Positions in Medical Images. And this is published at MICCAI 2025. So, and we took the leading open source models at that time. So from Mistral, we took the Pixtral 12B model. From DeepSeek, we took the Janus Pro 7B model. From Meta, we took the Llama 3.2 11B model. And from Google, then we later also integrated Gemma 3, the 12B model. So, and then we also included one closed source model. So we took the leading model at the time from OpenAI GPT 4o. So, and then we constructed the data set with over 4,000 CT slices. And for each slice, we generated a question. And the question is always about two anatomical structures that are visible in the slice, when we randomly select to the right, to the left, below, or above. So, for example, a question would be, is the liver to the right of the stomach? Well, and around 50% of the questions are correctly answered with yes, and about 50% of the questions are correctly answered with no. So, and now we always pass an image with the question together to the models, and they should answer with yes or no. So simple binary classification. So, and here are the results. So you can see here the accuracy, and that's the mean over 3 runs. So we always did 3 runs to report a mean and standard deviation. Well, and as you can see here, all models are around 50% accuracy. So we're basically at chance level, right? So this makes the use of those models for tasks like report generation or operation planning questionable. So I think when they perform so badly here, we cannot safely use them in the clinical routine. Otherwise we will result in this here. So we then thought, okay, how can we improve that? Well, one thing that is already pretty good in medical deep learning are segmentation models. So there you can take a CT slice and pass it through a segmentation model, and it will output the segmentation of, for example, anatomical structures. So of course, it will only output the segmentation of the structures it is trained for, but for like standard anatomical structures, that works already pretty well. But those models can only do segmentation. So you cannot ask them something about an image or let them write a medical report. So we thought, well, maybe we can combine segmentation models with the vision language models. So that when we have a CT slice, we first pass it to a segmentation model, and the model segments us the most important anatomical structures. Well, and then when we, for example, have the question, is the liver to the right of the stomach? With this segmentation, we can now put markers on the liver and on the stomach. So for example, this marker 1 and 2 here. And then we can also put the marker into the text prompt and ask, is the liver 1 to the right of the stomach 2? So that the model only needs to compare marker positions. So, and this is what we then pass to the models. So we tested several different markers. We tested numbers, letters, and red and blue dots. So, and here are the results. Again, the accuracy, mean over 3 runs, and we always reported the best marker type per model. Well, I think it's a little bit better now, but I think we're still here. I mean, even with a segmentation model, we can still not use this for tasks like report generation or operation planning. Well, but let's look at that a little bit more closer. What do we have here? So we asked, is the liver 1 to the right of the stomach 2? So the models really only need to compare marker positions. And we know that models can actually compare marker positions. For example, there's this paper, Set of Mark Prompting from 2023, where they show that the models actually can do that. So why is that so bad? Well, we did another experiment. So far, we always included the name of the anatomical structure in the question. So we included here the liver and the stomach. So now we will not do that. So we will erase them. So we will only ask, is the number 1 to the right of the number 2? Or is the letter A to the right of the number B? Or is the blue dot to the right of the red dot? So here are no medical names in the question anymore. So and those are the results. And as you can see, it's much better. So those were the same images. We just changed the text prompt. There are no medical names in there. And now GPT-4o, Pixtral, and Gemma perform very well. Well, but Janus Pro and Llama 3.2 are still not that good. So we did another study, which we call the ablation study. And there we just took white images and placed the markers on them. So there's no CT image in the background anymore. And then we ask, is the number 1 to the right of the number 2? And even with that, those two models are still not performing well. So it seems like those two models are just in general not good at comparing relative positions. But the other models are quite good, right? So let's look at them a little bit more closer. So we first had the question, is the liver 1 to the right of the stomach 2? And here they performed almost at chance level. And then we had the same image and we just did not put the medical names in it. So we just asked, is the number 1 to the right of the stomach? And suddenly they are super good. So they are generally capable of detecting relative positions, but they fail when we include the medical names in the text. So why is that the case? Well, we got an idea. So when we ask, is the liver to the right of the stomach? You can either answer that by looking at the image and answer it how it's actually at the image, or you can answer that by open an anatomy book and answer it how it's typically in most humans. Well, in those models here, I'm pretty sure that they have some human anatomy knowledge in their training. So they know where the anatomical structures normally are. So the question we then asked is, do the models ignore the images and just answer based on memorized anatomical knowledge? Well, to answer that question, we first have to clarify some definitions. So we have left, right, below, and above questions. So let's first look at the definition of left, right. Well, on an image, left, right is defined like that. This is the left side and this is the right side. Well, in human anatomy, the definition is the other way around. So this is defined as the right side and this is defined as the left side. So the anatomical left is on the image's right. So when the models answer anatomically correct, it is not the correct answer based on the image. But the models might know that and compensate for it by just mirroring the answer. Well, but there's something that I have not told you so far. The images are randomly flipped and rotated. So the models really have to look on the images to produce a correct answer. So now the definition for below and above. So in the image, this is above and this is below. Well, but in anatomy, there is no real below and above definition. There's anterior, posterior, or superior, inferior, but no real below, above. That's why we focused for this evaluation only on the left-right questions. So now back to our questions. Do the models ignore the images and answer based on memorized anatomical knowledge? We tested that the following way. So we had the images from our data set and we then have the left-right questions. So for example, is the liver to the right of the stomach? Then we passed them through the models that were in general capable of detecting relative positions, and they answer with yes or no. And then we evaluate the answers in two ways. So we evaluate them once image-based, so we look if the answers are correct based on the rotated and flipped image, and then we answer them anatomically. So we check if the models answer the questions right how it usually would be in standard human anatomy. So, and if the answer is correctly based on how it's normally in standard human anatomy, the answer must come from prior learned anatomical knowledge since it's not visible in the image. So let's first look at the results image-based. So do they answer correctly based on the image? Well, we already saw that before when we also included below above questions. The models here are at chance level. Well, then let's look if they answer anatomically correct. So as you can see here, at least GPT-4o and Gemma answer pretty good anatomically, and also Mistral not that bad. So it seems like most of their responses are consistent with the typical anatomical positions of the structures. So let's look again what we have here. So when we have this image and the question is the liver to the right of the stomach, it seems like the models ignore the images and answer just based on memorized knowledge of human anatomy, how it's typically the case in most humans. So, and we also tried different prompts here. For example, we tried as an initial prompt before the question, ignore anatomical correctness, focus solely on what the image shows, and we still didn't get any improvements. Well, and the funny thing is, about the same time when we published our paper, another paper came out that showed basically the same thing, but on color images. So it's called Vision Language Models Are Biased. And they, for example, took an image from a puma, but here in the image, the puma has 5 legs. So, and then they asked, how many legs does the puma have? Well, and all models answered with 4. So they ignored the image and just answered how it's usually the case for most pumas with their memorized knowledge. Well, and then they also had an image of an American flag. So, and here the flag has 14 stripes. So normally the flag has 13 stripes. So they asked how many stripes has the American flag. Well, and all models answered with 13. So how it's usually the case. So when we look at this question here, do models ignore the images and answer based on memorized anatomical knowledge? I think we can answer this question with yes now. Well, while this might be funny with the puma or the American flag, that is not so funny anymore in medicine. Let's remember where we came from. So we wanted in the end to use those models for writing a medical report or plan an operation. So, and when they answer based on memorized knowledge instead of visual evidence, that's pretty bad. So there are often cases where something is not normal, right? So for example, situs inversus, where organs are mirrored. So where the liver is then actually to the left of the stomach, to stay in our example. Or when people have a tumor, or after operation, things look differently, yeah? So I think we're still here. So when we look at our models again, we have two models that cannot detect relative positions at all. Even not in the simplest cases when we just ask, is the number 1 to the right of the number 2? So we definitely cannot use those models for writing reports or planning operations. Well, and then we have models that actually can detect relative positions. Well, that's good. However, if we ask them medical questions, they fail, because they answer them how it's usually the case in human anatomy based on prior learned anatomical knowledge instead of actually looking at the image. And that's of course also very bad. So I think there's a lot of work to do when we want to use those models for medical report generation or operation planning. Well, to push the research in this domain, we published our dataset we used for our evaluations as a new benchmark dataset, the Medical Imaging Relative Positioning Benchmark. So the benchmark dataset includes all the images, then with all the questions about the relative positions of two anatomical structures and the correct answers. And we also include the images with all the different marker types. Yeah, so and this is our paper, Your Other Left, Vision Language Models Fail to Identify Relative Positions in Medical Imaging, published at MICCAI 25.